Hey, I'm Noggs, and this is Noggs House. Today we're going to talk about something I'm using right now, speech. We're going to explore how humans went from simple grunts and gestures to being able to tell complex stories, share knowledge, and build entire civilizations all through the power of language. Long before humans could talk like we do today, our early ancestors still needed to communicate or share information with each other. They used rudimentary vocalizations. That's a fancy way of saying basic sounds like grunts, cries, and rhythmic noises. Think of the sounds a baby makes before they learn to talk, or the noises animals make. These early sounds were combined with gestures, hand movements, and body language to get messages across. The function or purpose of these early communications was pretty simple. Convey immediate needs, like I'm hungry or danger. Express emotions, such as happy, scared, or angry, and signal warnings to the group. Scientists have different theories or educated guesses based on evidence about how this evolved. The grunt theory says that simple instinctive sounds that came naturally without thinking, gradually became more complex over time. The vocal imitation theory suggests that imitating natural sounds, like animal calls or environmental noises like thunder, acted as a catalyst, or something that makes things happen faster. This may have laid the foundation for proto-language, which is a simpler, less structured form of language that came before real language. This shift marked the initial development of intentional communication, meaning our ancestors started making sounds on purpose to share specific information, not just reacting automatically. For humans to speak the way we do, our bodies had to change in some important ways also. The most important changes happened in the vocal tract. That's all the parts of your body involved in making sounds, including your throat, mouth, and tongue. Here are the key anatomical changes, or changes to the body structure. Lowering of the larynx. The larynx is your voice box, the part of your throat that contains your vocal cords, the parts that vibrate to make sound. In humans, the larynx sits lower in the throat than other animals. This was crucial for articulating or pronouncing clearly a wider range of sound. Increased tongue mobility. The human tongue became more flexible and could move in more ways. This was optimized or made perfect for precise articulation of diverse speech sounds, all the different consonants and vowels we use. An elongated pharynx. The pharynx is the space in your throat above the vocal cords. In humans, this space got longer, creating a longer resonating cavity, a space where sound echoes and gets louder. This enhanced or improved sound production, making speech clearer and louder. There were other changes too, like the enlarged hypoglossal canal, a bigger tunnel in the skull for the nerve that controls tongue muscles. This provided enhanced nerve supply, giving better fine motor control, the ability to make small, precise movements of the tongue. All these biological changes were essential for producing the building blocks of spoken languages, all the different sounds we need to make words. Changes in our DNA also played a huge role. DNA contains genes, pieces of code that tell your body how to develop and work. The most famous is the FOXP2 gene, sometimes called the language gene. This gene is linked to speech production and fine motor control of the face, controlling all the tiny muscles you use to talk. It influences embryonic development, how babies grow before they're born, of subcortical brain structures, parts deep in the brain that are vital for speech and language. There's also the NOVA1 protein variant, a human-specific genetic variant, a version of a gene that only humans have. Scientists think this is critical or super important for the emergence of human speech because it influences brain networks involved in vocalization or making sounds with your voice. What's really interesting is that this variant is not found in Neanderthals or Denisovans, other human-like species that lived long ago. This suggests it appeared uniquely in modern humans, highlighting the deep biological and evolutionary roots where something came from over millions of years of human linguistic abilities. Having the right vocal tract and genes isn't enough. You also need the right brain. The human brain has specialized areas, specific parts designed for specific jobs for language. The Broca's area is in the frontal lobe, front part of the brain, and is primarily responsible for speech production and language organization. Basically, it helps you form sentences and speak them out loud. Wernicke's area is in the temporal lobe, or side part of your brain, and is crucial for language comprehension, understanding what words mean. These areas work with complex neural circuits, networks of brain cells that link different parts of the brain together. These circuits connect cortical areas, the outer layer of the brain, with subcortical structures like the basal ganglia. All these parts working together are fundamental, or absolutely necessary, for the intricate motor control needed for speech articulation and for higher order cognitive processes or complex thinking like syntax and grammar. Humans have a unique capacity called reiteration, the ability to reorder a finite set or a limited number of motor gestures or movements to create a virtually infinite number or unlimited number of words and sentences. You can take the same sounds and rearrange them in millions of different ways. This cognitive flexibility, ability to think in flexible, creative ways, is also seen in music composition and dancing, showing how human brains are built for complex patterns. At some point, humans moved beyond just naming things and expressing basic emotions. They started constructing complex sentences, conveying abstract ideas that things that you can't touch or see, and recounting non-present events, telling stories about the past or planning the future. Grammar is the set of rules for how words go together, and syntax is the specific order words need to be to make sense. Together they provided the framework or structure for linguistic complexity. With grammar and syntax, humans could articulate intricate plans, explain complicated ideas for the future, discuss hypothetical scenarios, talk about things that might happen or didn't happen, and formulate detailed stories, or create complex narratives. There's a big scholarly discussion among scientists about whether this emergence was gradual and incremental, happening slowly bit by bit, or a more sudden cognitive spark, a quick change that happened all at once. We're still not totally sure. Scientists have different theories about where grammar came from. Nativism, supported by famous linguist Noam Chomsky, this theory says humans are born with an innate capacity, a built-in ability you're born with, for a language. Chomsky proposed something called universal grammar, the idea that the brain possesses fundamental grammatical principles or basic rules that are common to all human languages, no matter which language you speak. He also talked about a language acquisition device, an innate mechanism, built-in brain tool, for acquiring or learning language. This would explain rapid child language acquisition, how fast kids learn to talk despite limited exposure. Chomsky called this the poverty of stimulus. Kids learn language incredibly well even though they don't hear that many examples. How? Because some of it is already built into our brains. Empiricism. This theory says language, including grammar, is primarily learned through experience and environmental interaction, learning from the world around you. Children acquire language by exposure to linguistic constructions, sentence patterns, and meaningful contexts, real situations where those words make sense. Usage-based theory, or grammar from practice. There's another theory that's kind of in the middle called usage-based theory, supported by Michael Tomasello. This theory says that grammar and syntax emerge directly from language use and communicative function, the actual purpose of talking to people. The core ideas are meaning is use and structure emerges from use. Basically, children learn by discerning or figuring out communicative intentions, what people are trying to say, and identifying recurring patterns, knowing what happens over and over. The key cognitive skills needed are intention reading, understanding what someone is trying to communicate, pattern finding, noticing patterns in how people talk. In this view, grammar is seen as a derivative, or something that comes from something else, of language, not requiring a specific adaptation for universal grammar. Instead, grammar develops naturally from using language socially. Social interaction is also seen as a crucial driver or main force for grammar evolution and development. The need to communicate, exchange information, and engage in shared intentionality, working toward a common goal, or joint attention, two people focusing on the same thing together, in cooperative acts push language to develop. Language is used as a deeply social construct, something created by society. Speech had a transformative impact. It changed everything on early human societies. Social cohesion means people sticking together and cooperating, and this was vital for survival in hunter-gatherer groups. People who got food by hunting animals and gathering plants. And here's how speech helped. Sharing experiences and skills transmitted vital information and fortified or strengthened interpersonal relationships, the relationships between people, fostering or encouraging trust. Storytelling, rituals, and narratives preserve cultural identity, what makes a group unique, and cemented or locked in group cohesion, cultivating or creating a sense of belonging. Speech was used to organize communities, negotiate conflicts, or work out disagreements, and establish rules. solidifying or making solid social structures and leadership. Emotional articulation, or expressing feelings with words, deepened empathy or understanding how others feel and interpersonal connections. Even informal communication like gossip reinforced or strengthened social norms or rules about how to behave in group trust. Language is intimately linked or closely connected with societal development, underpinning or supporting social norms, beliefs, and shared cultures. It's what makes humans truly social beings. Speech revolutionized, completely changed, knowledge transfer, especially across generations, from parents to children to grandchildren. Before writing systems existed, oral traditions, stories and information passed down by speaking, were the primary means or main way of preserving cultural identity, moral values, ideas about right and wrong, and practical wisdom, useful knowledge for everyday life. Speech facilitated or made possible detailed instruction in essential skills like tool crafting, plant identification, knowing which plants are good to eat, and hunting strategies. Storytelling's role was huge. Stories helped make sense of the environment, conveyed survival strategies, and imparted or shared crucial moral lessons and cultural traditions. Early language education equipped or gave tools to younger generations with understanding to navigate their world and contribute to the community. The continuous sharing of knowledge, practical know-how or skills, scientific observations, technological advancements or new inventions propelled humans' progress, leading to collective intelligence, the combined knowledge of the whole group. Thanks so much for hanging out with me today at Nog's House. We've learned how speech is this amazing complex tapestry or mixture of biological adaptations, cognitive breakthroughs, and social necessities. From basic grunts to intricate grammar, speech transformed individual humans into deeply connected, knowledge-sharing communities. Speech solidified social bonds, enabled cooperation, culture, and collective learning. It allowed us to share stories about the past and possibilities for the future, fostering innovation and ensuring the survival and flourishing of our species. Speech truly became the foundational technology of humanity. But our story isn't over yet. Next time we're going to talk about the social brain, how human brains evolved specifically to handle complex social relationships, understand what others are thinking, and cooperate in groups. How did our brains get so good at being social? I hope you'll come back and join me for that. See you next time.